Hello everyone. Today let's start the topic sets, which is from unit 1 discrete structures of paper 2 computer science. Let's begin with the definition of set in the next slide. So what is set? The definition of set is a set is a well defined collection of distinct objects. Distinct object means the elements of the set should be unique, no duplication should be allowed, and well defined collection means the elements of the set should share some common attribute or some common properties. Okay, and the set is defined by capital letters like A, B, C, etc. Let us discuss few examples of set. Suppose the set of natural number. Set of natural number is represented with capital N, and the elements of natural number set is the number starting from 1 to infinity, 1 2 3 and so on up to plus of infinity. This is the set of natural number. And there is a set of integers in which the elements are minus infinity including 0 up to plus of infinity. So these are the two sets. Okay, few more examples are there, like set of vowels. Vowels means elements are A, E, I, O and U. The set of vowels consists of 5 elements, that is A, E, I, O, U. Okay, so the most important thing we have to remember is no duplication should be allowed. That is, the elements should be distinct. If I define a set in which I have defined elements like 1, 2, 3, 1 and 3. So is this a valid set? No. Why? Because the elements of the set should be unique. Okay, so no duplication is allowed. If it is a set defined, then we can consider one element only once. Okay, and the properties that the element should have should be similar. Okay, so let's see how we can represent the sets. There are basic two methods or two types of representation of sets. What are those? The first one is the roster form and the second one is the set builder form. Okay, the roster form is the form in which I have defined the set in my previous slide. That is, the elements are listed and separated by commas inside the curly braces. Suppose I have defined the set of vowels in which the elements are A, E, I, O and U. Okay, so these are the elements of the set, and these elements are enclosed under the curly braces, and each elements are separated by commas. So this type of representation is known as the roster form, in which each element is defined inside the curly braces. Okay, so this is the roster form. Or suppose I have defined a set of consonants like small letter A, B, C up to small z. So this is also a representation of roster form in which the elements are defined inside the curly braces itself. Okay, so the another form is the set builder form. In the set builder form, we do not express elements of the set inside the curly braces. Instead, we have to define the properties of the elements. How is it possible? See how the sets are represented in the set builder form. Suppose I have to define the set of natural number, so I will define it in the form of variable. Okay, so I have considered a variable x in which x is natural number. Simply I have written the property of the elements that x is a natural number. So this is the way we define in set builder form. I have considered a variable x. The property of variable x is what? That x is a natural number. Suppose I have defined set of real numbers or set of integers, then I have taken one more variable like y, and the property of y is integer. Okay, like if I have to define the set of vowels, then I will define a variable, suppose x, and what is the property of x? X is vowel. Simply we have to define the property in this manner. So this is the representation known as set builder form. Okay, now let's move to another topic, that is the cardinality of a set. Cardinality of a set means number of elements present in the set. How many number of elements are there in the set is known as the cardinality of set. Okay, firstly we have declared a set of natural number which starts from 1 and to the plus of infinity. So how many number of elements are there? We cannot count. Okay, so uncountable number of elements are there. So the cardinality of the set of natural number will be infinity. Okay, and suppose I have defined a set of consonants from elements a, b, c and to the element z, then how many number of elements are there? 26 elements are there. Okay, okay, so the cardinality of set of consonant is 26. Okay, so next is, okay, so let's move to the next slide. Next is the types of sets. Okay, first one is the empty set, a set having no elements or whose cardinality is 0, means a set in which there is no element. So now you will think that is this possible that a set is there in which no elements is there or the cardinality is 0? So the answer is yes. Suppose I define a set A in which there is a variable and the property of variable is x is natural number and x equals to no, x is consonant. So what does it means? Is there any variable which is natural number as well as consonant? No. So this set is empty. And for empty set, we define a variable that is phi. Okay. For empty set, we defined it as a phi. Okay. So in this case, set A can be defined as phi or null. Okay, next is the finite set. Finite set means a set having finite number of elements. Finite number of elements means countable number of, if there is a set in which countable number of elements are there, then it is known as finite set. Like set of consonants or set of vowels. Set of consonants is defined as A, B, C and so on up to the set element Z. So the number of elements are 26. So this is a finite set. Set of vowels, elements are A, E, I, O and U. So the elements are finite. So this is known as finite set.